In this video, we are going to analyze organic compounds qualitatively, and this part will be mainly focused on preliminary examination. Steps to analyze the organic compound, and the first we will do is physical examination of the organic compound, that is state, color and odor. Then ignition test, that is the flame test for unsaturation. So these are the preliminary test, and then we will do detection of elements, that is nitrogen, sulphur and halogen. For that we have to prepare the Lassaigne extract, we have to prepare sodium extract. We will do solubility test, and according to that we will group the organic compounds in 1 to 7. So next we will do is functional group analysis. Sequence of tests we will perform to analyze which functional group is present. And the last, to confirm it, we will do melting and boiling point determination for confirmation of organic compound. Preliminary examination includes state, color, odor, flame test, solubility and detection of unsaturation. First is the state of the compound, whether the compound is solid or liquid. If the compound is solid, then it can be carbohydrates, acids, phenols, amines or sugars. And if the compound is liquid, then it can be alcohols, ethers, esters, aliphatic amines, aldehyde ketones and hydrocarbons. So according to that, we have in view that which organic compound it is. Then we have the color of the compound. We have colorless compounds such as alcohols, aldehydes, ketones, carboxylic acids, simple hydrocarbons. As you can see, these ethylene glycol, all these are colorless. Pink color is of alpha naphthol, beta naphthol and resorcinol. Dark brown color is of phenols, as you can see how phenols look like, and amines. Yellow color compounds are mainly nitro compounds such as nitrobenzene, dinitrobenzene, nitrophenols. As you can see, nitrobenzene sample looks like this. Odor of the compound. So bitter almond odor is of nitrobenzene and benzaldehydes. Then esters are of pleasant fruity smell. Sweet odor is of alcohols. Phenols gives phenolic odor, not very good to smell. And lower acids and aldehydes gives irritating pungent odor. It brings tears to our eyes also. Then we have is vinegar-like smell, that is because of acetic acid. And fish-like smell is of aliphatic amines or aromatic amines. So odor will also help us to detect. Next is a flame test. For this, we will take organic compound on a nickel spatula, and over a low flame, we will note the color of the flame and the odor coming out. Non-sooty flame is of aliphatic compounds. Sooty flame is given by aromatic compounds. As you can see in the video, it is giving non-sooty flame, so aliphatic compound. And sooty flame is given by benzene, which is an aromatic compound. Charring with smell is given by carbohydrates, and if charring and swells without melting, then sulfur containing compounds may be present. Then next is the solubility. For that we have grouped the compounds in 7 groups. So first we will try to solubilize the compound in water. Group 1 and group 2 compounds are soluble in water. To distinguish between these, we will solubilize these compounds in ether. If it is soluble in ether, then it belongs to group 1, that is low molecular weight compounds such as acid, alcohol, aldehyde ketones, ester, phenols. And if it is insoluble, then it can be sugars and amides. So we can distinguish on the basis of solubility in ether. So for the group 3, if the compound is insoluble in water as well as in ether, then we will move to the group 3. We will try to solubilize it in dilute HCl. If it is soluble, then it can be amines, primary, secondary or tertiary amines. If it is insoluble in dilute HCl also, then we will try to solubilize it in dilute sodium hydroxide. This group includes acidic functional groups, that is acids and phenols. So, if the compound is insoluble in dilute sodium hydroxide, then we will move to next group, group 5. We will try to solubilize the compound in concentrated sulfuric acid. If it gets solubilized, then it can be aldehyde ketones, alcohols or esters, provided nitrogen is absent. If it is insoluble, that can be hydrocarbons or halogen hydrocarbons. If the compound is insoluble in dilute NaOH and nitrogen is present, then that can be because of nitrogen containing compounds, that is amides, analytes, etc. So from this flow chart we can easily understand. We will try to solubilize in different solvents, that is water and then ether, then dilute HCl and then dilute NaOH. If the compound is soluble, then we have group 4. If insoluble, then group 5 and group 6 compounds will be there, or group 7 compounds may be present. So, solubility will indicate which organic compounds it may be. Detection of extra element, that is nitrogen, sulphur or halogen. For this, we will prepare Lassaigne extract. We will fuse the organic compound with the sodium metal and we will prepare the sodium salts of nitrogen, sulphur and halogen. If the nitrogen is present, then it will form sodium cyanides. If the compound is having sulfur, then it will form sodium sulfide. If it contains halogens, then sodium halides. And if it contains nitrogen and sulfur both, then thiocyanates will be synthesized. Preparation of Lassaigne extract. To prepare Lassaigne extract, we will take an ignition tube and place a dry sodium metal and we will heat it to form a shiny bead in it. You can see in the video a shiny bead will form, and then we will add a little quantity of organic compound in it and then we will heat it gently and then we will heat it strongly to make it red hot. Then we will plunge this ignition tube in porcelain bases and we will heat it to reduce the volume up to 1/3. So this how we have prepared Lassaigne extract. In this process, we have to be careful that we should not touch the sodium metal with the bare hands. We handle it with the forceps and there may be slight explosion with the compounds such as nitroalkanes, azides, diazonium salts and chloroform, etc. So, in this preparation, we have to be little careful in handling sodium metal. We should not touch it with the bare hands. We should use forceps. There may be slight explosion with the compounds nitroalkanes, azides, diazonium salts, chloroform or carbon tetrachloride. So, must wear the safety goggles and lab coats while handling this preparation. Test for nitrogen. For this, we will do ferrous sulfate test. So, we will take Lassaigne extract and then we will add ferrous sulfate. Then it will be converted into sodium ferrocyanide. Boil this mixture gently for few seconds and then after boiling, we will acidify it with dilute sulfuric acid. The ferric ions generated during the process reacts with the ferrocyanide to form Prussian blue precipitates, and Prussian blue compound indicates the presence of nitrogen. So the compound synthesized is ferric ferrocyanide. Test for sulfur. In this, we will perform lead acetate test. So, we will take sodium extract, then we will acidify it with the acetic acid, then we will add few drops of lead acetate solution. Appearance of black precipitates indicate the presence of sulfur. The black precipitates are of lead sulfide. Tests for nitrogen and sulfur both present together in an organic compound. So for this, we will perform ferric chloride test. We will take again the sodium extract and then we will acidify it with the hydrochloric acid, dilute acid we will use. Then we will treat it with ferric chloride solution, and on adding ferric chloride solution, blood red color will appear, which indicate the presence of nitrogen and sulfur both. Next is test for halogen, that is silver nitrate test. We will take sodium extract and then we will acidify it with dilute nitric acid. Then boil the mixture gently and to expel out hydrogen cyanide and hydrogen sulfide. On adding silver nitrate solution, we will obtain these white precipitates. So, we will filter these white precipitates and then we will try to solubilize it in ammonium hydroxide. If it get readily soluble, then in ammonium hydroxide, then chlorine is present. If we obtain pale precipitates and which are soluble in excess of ammonium hydroxide, bromine is present. If yellow precipitates are obtained and which are insoluble in ammonium hydroxide, iodine is present. Next is test for unsaturation, that is double bonds and triple bonds. So we will perform two tests. First is bromine water test. In this we dissolve the organic compound in carbon tetrachloride. Then we will add the bromine solution drop wise with shaking. The bromine water is of brown color. As soon as it will enter our mixture, the color will get discharged, which indicates the presence of unsaturation. So you can say bromination has taken place on the double bond and colorless solution will be obtained. Next test for unsaturation is Bayer's test, that is reaction with potassium permanganate. For this, dissolve the organic compound in water or acetone, then add aqueous solution of potassium permanganate dropwise. The brown precipitates, that is decolorization of KMNO4 color, indicates the presence of unsaturation.